Today's lesson, we shall be looking at what? Logarithms. Logarithms. Now, when we talk about logarithms, it can be explained as the power to which a number must be raised to produce some other values. It can be explained as the power to which a number must be raised to produce some other values. So when you have log of b to the base of a, the a becomes the base, b becomes the number, and then the logarithm is shortened and written as log. So this is read as log of b to the base of a. Now from the definition, this can be explained as to what power must a be raised to produce b. In other words, a raised to what power will give us b. Now writing this or translating this mathematically, we are saying that a raised to what power? We don't know that power. So let the variable x represent that power. So a raised to what power? So a raised to what power will give us what? B. So this is the meaning of that. Log of b to the base of a means that to what power must a be raised to produce b? Since we don't know the power that a must be raised to produce b, let's call that power x. So this becomes the general form for logarithms. The x becomes the index or the exponent, the a becomes the base, and then b becomes the argument, which is what? A positive number. So from this, when you have log of 8 to the base of 2, this can be explained as to what power must 2 be raised to produce 8? In other words, 2 raised to what power will give us 8? And we can write it as 2 raised to what power will give us 8. So this is the meaning of log of 8 to the base of 2. Similarly, when you have log of 81 to the base of 3. Now this can be explained as to what power must the base, which is 3, be raised to produce the number 81? In other words, 3 raised to what power will give us 81? And we can write it mathematically as 3 raised to what power will give us what? 81. Last but not the least, when you have, we can write it as what? 5 raised to the power x is equal to 125, which means that what power must we raise the base, which is 5, to give us what? 125. In other words, 5 raised to what power will give us 125. Now let's look at something. So we said that b is equal to what? A raised to the power x. And this is the exponential form of this logarithm form. Now if we want to write this in a logarithm form, or we want to go back to the logarithm form, this is what we must do. Now this is the base of the x. So the base of the x will move and become the base of the logarithm. So we are going to introduce logarithm on b, which is the number, and then we have a raised to the power x. Now once we have this base will move and become the base of the log. So we will have log of b to the base of a is equal to x. We are back to the logarithm form. So if you have the logarithm form, which is this, and then you want to write it in an exponential form like this is what we are going to do as well. So we want to write this in an exponential form. Now the base of the logarithm will move and become the base of the power or the index. So you have the base of the logarithm will move and become the base of the power or the index. So you have a raised to the power x. We are left with what? B. We are back to the exponential form. This is one of the reasons why we normally say that indices and logarithms are inverse operations. In other words, they are the reverse of each other. Let's look at the following. Now we want to look at this. But before we start with it, let's kindly take note of the following. The base of a logarithm can be written in any number, any positive number, with the exception of what? 1. Take note of that. And then the logarithm of a negative number does not exist. Take note of that one as well. Now, when the base of a logarithm is not written, we assume that that logarithm is in base 10. Take note of these three things. Now, let's look at this. We want to convert the following into an exponential form and then vice versa. That is, we want to convert it back to in a logarithm form. So we have the following. Log of 81 to the base of 3 is equal to 4. We want to write this in an exponential form. So applying the concept, or earlier we said that when you have log of b to the base of a is equal to x, now the base of the logarithm will move and become the base of the exponent. So you have a raised to the power x, we are left with what? B. We are going to apply this concept to express this as what? That. So this is the base of the logarithm. It will move and become the base of the exponent. So you have 3 raised to the power 4. We are left with what? 81. As easy as that. Now let's look at this one. We want to express this in an exponential form. So applying the earlier concept, this is the base of the logarithm. It will move and become the base of the index or the exponent. So you have 27 raised to the power 1 over 3. We are left with what? 3. Very, very easy and then simple. You can try your hands on the third one. We have C. So applying the concept, this is the base of the logarithm. So it will move and become the base of the index. So we have 3 raised to the power negative 2. We have what? 1 over 9. As easy as that. This is how we convert a logarithm form into an exponential form. Now you want to move back and write this index form to a logarithm form. So you want to write this in a logarithm form. So we are going to apply this concept, which we said that if you have b is equal to a raised to the power x. Now if you want to write this in a logarithm form, we are going to introduce logarithm on the number which is b, and then the base of the x will move and become the base of the logarithm. So you have log of b to the base of a is equal to what? X. So we are going to apply this concept to express this in a logarithm form. So we have 81 is equal to 3 raised to the power 4. So we are going to introduce our logarithm. We have log of 81, and then the base of the power will move and become the base of the logarithm. We are left with what? 4. Very, very easy. This is the logarithm form of this, and we are back to the logarithm form. Now let's look at the last one. You can try your hands on example C. You want to write this in a logarithm form. So we are having 3 is equal to 27 raised to the power 3. So we are going to introduce logarithm on 3, then the base will move and become the base of the logarithm. We are left with what? 1 over 3. So this is how we convert a number in a logarithm form to an exponential form, and then vice versa. Now that we have this, let's look at evaluating logarithms. So we want to evaluate the following logarithms. In other words, we want to find the value of each of these logarithms. So let's start from this side. We have log of 0.25 to the base of 2. Now this can be explained as to what power must we raise 2 to give us 0.25. In other words, 2 raised to what power will give us 0.25. So we can write it mathematically as 2 raised to what power will give us what? 0.25. We can also use another approach where you have log of b to the base of a, we equate it to what? X. So when you have log of 0.25 to the base of 2, we equate it to what? X to any variable at all, not x to any variable. So once you have this, we are going to express this in an exponential form. So the base of the logarithm will move and become the base of the exponent, which is x. So you have 2 raised to the power x, we are left with 0.25. So whichever approach that you use, you are going to land at this very part. So let's continue. So we have 2 raised to the power x is equal to. Now I want the base on either side of the equal sign to be the same. Therefore, we have to express 0.25 in a fraction form. And we know that this can be written as what? 1 over 4. Now, applying the negative index property of indices, we see that when you have 1 over a, we can write it as a exponent negative 1. So 1 over 4 can be written as what? 4 raised to the power negative 1. And we know that 4 can be written as what? 2 raised to the power 2. Because this will give us 2 times 2, and we have 4. So we are going to have 2 raised to the power 2, and then negative 1. Applying the power law, we are going to have 2 raised to the power negative 2. So in place of this, we are going to have 2 raised to the power negative 2. So we have 2 raised to the power x, and then we have 2 raised to the power negative 2. Now, once the bases are equal exponential equation, what do? We equate their exponents. So we have our x is equal to negative 2. Very, very easy and then simple. So with this, we can equate it to any variable at all. So let's say the variable x. So once we have this, we are going to convert it into an exponential form. So the base of the logarithm will move and become the base of the x. So we have 8 raised to the power x. We are left with what? 64. Now I want the bases on either side of the equal sign to be the same. So we can rewrite 64 as what? 8 raised to the power 2. Because 8 times 8 will give us what? 64. And this can be written in this form as what? 8 raised to the power 2. Now once the bases are the same, we can equate their exponents. So we have our x is equal to 2 as easy as A, B, C, D. You can pause the video, you try your hands on this. So we can equate this to any variable at all. So let's say the variable x, we express this in an indical form where the base of the logarithm will move and become the base of the x. So we have 2 raised to the power what? X. We are left with what? 32. Now I want the bases on either side of the equal sign to be the same. So we can write 32 as what? 2 raised to the power 5. So we have 2 raised to the power s. Once the bases are the same, we equate their exponent as easy as A, B, C, D. Now let's look at this. So we are saying that to what power must we raise 10 to give us 1,000? So you can equate it to any variable at all. Let's say x. So we have 10 raised to the power s is equal to what? 1,000. You want the bases on either side to be the same. So we have 10 raised to the power x. You can write 1,000 as what? 10 raised to the power 3. Once the bases are the same, we equate their exponents. Very, very easy. This brings us to the end of today's lesson. So, these are tutorial set questions. See you tomorrow. Bye bye.